In progress.
Hello dear students, today we are going to discuss about very important concept called hybridization. From this concept, minimum 4 to 5 questions came in previous competitive exams, and in this mainly finding hybridization of central atom in molecule, number of lone pair bond pair electrons in the molecule, along with that finding shape of the molecule, and then bond angle of the molecule, and among the following pair which are isostructural isoelectronic spaces. All those things came in the previous exams. So how to find answers for those questions we can discuss in this video. So hybridization is nothing but it is intermixing of atomic orbitals. Intermixing of atomic orbitals. So here first thing is how to find hybridization. Let us take any molecule BeCl2 or AlCl, the FeCl, BeCl3, BCl3, and then CH4, and then CO2, and then NH3. Like that we can discuss. Just to take first example, which is called BeCl2. So in this, beryllium is central atom. So atomic number for beryllium 4. So electronic configuration 2, 2 or 1s2, 2s2. We can write electronic configuration in any way. And here, since the 2 electrons present in the last shell, just to take those 2 electrons like this, and surrounding atoms are 2. One is, those 2 are Cl atoms. So let us take number of hybrid orbitals here 1 and 2. So total number of hybrid orbitals in this molecule just to 2, so that the given molecule central atom hybridization is sp. So in this case, number of hybrid orbitals equals to hybridization. So here 1 and 2, so that 2 hybrid orbitals. So 1 plus 2. So 1 s orbital, 1 p orbital involved in this. So the hybridization of Be in BeCl2 sp. When the hybridization is sp, shape will be linear molecule and bond angle will be 180 degrees. So in this case, percentage of S character is 50%, and similarly P character also 50%. So total number of hybrid orbitals percentage is equals to 100. So each one will be 50-50. So that is how we can able to find hybridization of any element, any central atom in the given molecule. And coming to the second thing, that is BCl3. So in this case, boron is central atom. So if you know group number, directly we can write that many electrons as valence electron of that element. If you don't know, just to take atomic number, which is 5, electronic configuration 1s2, 2s2, and 2p1, which is also represented as 2, 3. In the last shell, we have 3 electrons. So we can write 3 electrons like this, and surrounding 3 chlorines are connecting like this. So we have total 3 hybrid orbitals. So 1, 2, 3. So hybridization is sp2. So 1 s orbital and 2 p orbitals. So finally we get 3 hybrid orbitals. So that the hybridization of B in BCl3 is sp2. So this is, and if it is sp2 hybridization, the shape will be trigonal planar, and the bond angle will be 120 degrees. Suppose if the central atom is oxygen or nitrogen, little different way we have to find hybridization of central atom. So suppose we can take CO2. In this, carbon is the central atom. So valence electrons are how many we have? So same thing, atomic number 6, electronic configuration 2, 4. So we have 4 electrons in their outermost shell, just 4 electrons I'm writing like this, and making here oxygen, if it is central atom, one oxygen combines with two electrons like this. So one surrounding oxygen can combine with two electron of central atom, so that number of oxygen atoms gives number of hybrid orbitals. So we have two oxygens, so the hybridization is sp. And if it is sp, we already know that the shape is linear molecule and 180 degrees bond angle. If bond angle is 180 degrees, the dipole moment value will also 0. So this is how we can calculate if oxygen is acting as a central atom. Suppose if it is nitrogen as central atom, let us take N2 molecule is an example for this. So in these two nitrogens, one nitrogen act as a central atom. So for that nitrogen, we have total 5 electrons, because nitrogen atomic number 7, electronic configuration 2, 5. So we have total 5 electrons in their outermost shell. So those 5 electrons I written here like this, and coming to the connection with surrounding atoms. So out of two nitrogen, one is central atom, the another one is surrounding atom. So that one nitrogen bond order is 3. So it connects with 3 electrons of central atom like this, and this will be act as a lone pair. So 1 and 2. So total we have 2 hybrid orbitals, so that we can see the hybridization is sp. So here you may get one more doubt. So in any case, if lone pair is left out, so that lone pair can give one hybrid orbital like this. So that is how we can say the hybridization is sp with a lone pair of electrons. With a lone pair of electrons. So this is how we can find the hybridization of central atom in any molecule. Since one more is there, that is, suppose if it is SO4 minus 2. SO4 minus 2. In this case, sulfur is central atom and oxygen are surrounding atom. This charge, whatever they mentioned charge, that charge belongs to central atom only. If they specify with a negative charge, which indicates we need to add those number of electrons to the central atom. So we already know that sulfur atomic number 16. Electronic configuration we can write 2, 8, 6, right? So if you don't know this, just you can write this formation, this format also, that is 1s2, 2s2, 2p6, 3s2, and 3p4. So in the last shell, we have total 6 electrons. So 2 plus 4, 6. So those 6 electrons we can represent like this. And here again minus charge they mentioned over the ion. So that minus also we need to put here like this. So since 2 minus, we added 2 extra electrons. Now come back to oxygen. Just now I told already, if oxygen has a surrounding atom, 2 electrons of central atom can connect with one oxygen atom like this. So that is how the connections will happen. And hybrid orbital number is equals to number of oxygen atoms present in this. So we have total 4. So the hybridization is sp3. So that is how we can find the hybridization of central atom in the ion as well. Suppose I3 minus. So in this case, and iodine is the central atom. Out of 3 iodines, one act as a surrounding atom. Sorry, one act as a central atom. The rest all are acting as a surrounding atoms. So in this case, iodine belongs to 17th group. So just I'm taking directly electrons 7 here. 1, 2, 3, 4, 5, 6, and 7. So out of 3, one acting is surrounding central atom. So I return 7 electrons here. The rest to 2 iodines combines like this. And before going to this, just here they mentioned minus also. So one more electrons we have to put for central atom like this. So after connection of 2 surrounding iodines like this, the just lone pair of electrons are here. So already told you, every lone pair can make one hybrid orbital. So from these 6 lone pairs, we get 6, and this is 4. Sorry, from 3 lone pairs, we get 3 hybrid orbitals, 4 and 5 hybrid orbitals. So that is how we get 5 hybrid orbitals, means sp3d hybridization, 1 s orbital, 3 p orbitals, and 1 d orbital. So we get totally 5 sp3d, 5 hybrid orbitals, which indicates sp3d hybridization. And the shape of the molecule, it will differ from trigonal bipyramidal, so that we need to understand sp3d with a lone pair, sp3d without lone pair, trigonal bipyramidal, and then seesaw shape, T shape, all those things will be here.